In this video, we're going to be taking a look at the factoring decision chart. When you're approaching a problem, you have to know how you're going to factor it, and that's going to be based upon what information you see in front of you. For instance, if you have either two terms or if you have three terms, that's going to change the direction that you go. When you have two terms, you're either going to look at it as a greatest common factor problem or a difference of squares problem. So remember, greatest common factor is something that goes into every single term that you see, and a difference of squared problem is if you have two terms that are being squared and there's a difference in between them. So let's start by taking a look at the greatest common factor. Right, so all of these examples here are examples where you're going to use a greatest common factor. Note there are all going to be two terms. And so what your job is to figure out what is it that comes out of each of those terms. And so as you take a look, you say, okay, well, 7x plus 14, that means a 7 can come out. You're reversing your distributive property. It's going to be 7 times the quantity, x plus 2. X squared minus 10x would be an example where you see that you have an x in each of these problems. And so you're going to pull an x out and you have x minus 10. I know there are a lot of students that had difficulty with this example on some previous assignments rather. And so if you have an x that goes into both, you can pull an x out. Yes, this is a squared, but 10x is not squared. That's why it's a greatest common factor problem and not a difference of squares. Moving on, we take a look at our next one. You have 3k cubed plus 12k. And so a 3 goes into both 3 and 12, and a k can come out. And what you're going to have remaining is k squared plus 4. Right? And so as you take a look, k squared times k is going to be k cubed, and then you have a plus 4 here because that multiplied by 3k is 12k. And our final example, as we take a look, in this example you see that you have a negative out front and both, so I'm going to pull a negative, and a 3 goes into both 18 and negative 3, and so that means that I have 6y plus 1 as your factor that's remaining. And so you're just reversing your distributive property, finding out what can come out front of a set of parentheses for both or all terms. And that's your greatest common factor. If you take a look at your two terms and you realize it's a difference of squares problem, then you're going to have a couple different examples. So here are 4 different problems. You notice that all of these have two terms again, because that's the bracket we're in, and you're all subtracting them, and each of the terms are a square quantity. And so as we continue to factor these, all right, well, I can be x plus 9 and x minus 9 because that 9 times 9 is 81. Or it could be y plus 5 and y minus 5 because that 5 times 5 is 25. As we look at your third example, both of them have a square number it, so you're going to have 3x to begin with, and then it's going to be plus 10 and minus 10 in order to get 100. And for your last example, same concept. You're going to have two different quantities that can be squared, so you have 4x to lead off to get you a total of 16x squared, and you have plus 8y and minus 8y. And that's how you do all of your difference of squared problems. Note it's not about just the difference, it's not about just having squared, it's got to be a difference of two squares in order to apply that shortcut. Third, if you have a 3-term problem. Now, our first thing here says greatest common factor with a question mark. You should always check first to see if your 3-term problem, your trinomial, is going to have a greatest common factor. Afterwards, then you can either do a generic rectangle and diamond problem, or perhaps just a diamond problem. We're not too concerned about level 1 versus level 2, but you do need to know how to factor a trinomial. So let's take a look at some examples of a 3-term or a trinomial. Note in all 3 of these examples you have an x squared, an x, and just a 1s, and that's how you know you're going to do some factoring. If I look at the first one, I see I have a 2x squared, 9x, and a negative 5. And no, there is no greatest common factor. For the second one, an x squared, a 10x, and a negative 11. Nope, there's no greatest common factor there either. But for the third one, 4x squared minus 2x minus 12, there is a greatest common factor of 2. And so as we take a look at those, we'll kind of jump into how to factor them. So I did a little shortcut here. I'm going to zoom in, right, for these trinomial problems. And so you have your generic rectangle that you set up. In our previous video, had some examples on how to do that. And so you also set up your diamond problem. And once you set up your diamond problem, you figure out what goes on the left and the right side. So negative 10x squared because that's the product. And so then you're going to have a positive 10x and a negative 1x. And that fills in our boxes here. And then we have to factor what's remaining. Here there's a 2x. Here there is an x, and we have a -1, and you have a 5. And so your final answer for this one is 2x minus 1 and x plus 5. And that's your factored version of this. For the second example, x squared and -11. And so you have a -11x squared on top. And then with left and the right side, here you're going to have 11x and a -x. Okay, kind of similar to the previous example. And so those are going to go in your boxes that are open. It doesn't matter which one. And when we factor out, we have an x here and an x there. And then this is a 11 and this is a -1. And so this factored version is x plus 11 and x minus 1. Now that's why in this example we have a level 1 and level 2. If you always want to make the generic rectangle then diamond problem, please feel free. But we're just saying that if a equals 1, which is your leading coefficient out here, that the diamond problem is enough. Meaning here we have a diamond problem, you have 11 and a -1 out in front of your x's, and that's the value that goes inside your parentheses. But the generic rectangle is a great way to always get the right answer. Now this third example is the one that we said we had a greatest common factor of 2. So we're going to pull a 2 all the way out, and so then you have 2x squared minus x, and then minus 6. So note that is how this generic rectangle is set up. That's really important that you always do that first, where you pull out your greatest common factor. Trust us, it'll make the rest of the problem a lot easier. And now what we fill out, say, okay, well this has to be a -4x, and this is a positive 3x. You fill those in those boxes, and you factor out what's remaining. Here's your 2x and an x. This is -2 and a positive 3. And so your factors here are 2x plus 3 and x minus 2. However, you do need to include that greatest common factor in your final answer. And so that's where having a greatest common factor in your trinomial comes into play when you are doing your factoring. So this video captures everything that we've talked about in this unit so far and how to factor all these examples. Lots of different problems here, but that's how you make your decisions.